In Formula 9, which is the compound angle formula, we're looking to prove that tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B. So the first thing that we're going to use to help us in this proof is that tan of any angle, it's in our log tables as well on page 13, tan of an angle is equal to sin of that angle over cos of that angle. So say tan of any angle A is equal to sin of that angle over cos of that angle. The reason for this we'll go over just quickly. So say if we have a triangle and this is our hypotenuse, this is our opposite, and this is our adjacent. So the sin of that angle is opposite over hypotenuse. The cos of that angle is adjacent over hypotenuse, and again this is in our log tables. And the tan of an angle is opposite over adjacent. So if we're to get, so if we want to show that tan of an angle is sin of that angle over cos, so sin of the angle is opposite over hypotenuse, and putting that over cos of the angle, which is adjacent over hypotenuse, and multiplying top and bottom by h, we get O over A, which is equal to the tan of our angle A. So sin over cos of the same angle is equal to tan of that angle. So because we want to deal with tan A plus B, we're going to have the tan A plus B, and then it'll be is equal to sin A plus B over cos A plus B. And now I'm going to write this out differently. So cos A plus B and sin A plus B. So I'm going to write cos A plus B in this form here. So on my log tables, page 14, I'm going to rewrite it in the form given here, and sin A plus B, I'm going to rewrite it as given here. So tan of A plus B is equal to sin. So I'm rewriting sin A plus B as what's given here in my log tables. So instead of, so sin A plus B is equal to sin A cos B plus cos A sin B. So this is the expression given in our log tables here, and then cos A plus B is equal to this. So cos A plus B is equal to cos A cos B minus sin A sin B. So now I'm going to substitute, instead of writing sin A plus B, I'm going to put in this here. So sin A cos B plus cos A sin B. And then instead of writing cos A plus B, I'm going to replace it in with here. So I have cos A cos B minus sin A sin B. So now that I have my expression here, what I want to do is I want to try and get it in this way that we were given we had to prove. So one way, the next step I'm going to take is dividing top and below. So the top of the fraction and the bottom of the fraction, which I can do if I divide by the same thing, by cos A cos B. So we're dividing top and bottom by cos A cos B. So sin A cos B plus cos A sin B. So that's going to be divided by cos A cos B, and then cos A cos B. And similarly the bottom of our fraction, which is cos A cos B minus sin A sin B, which is going to be divided by cos A cos B, cos A cos B. So now we're going to work to simplify this. So if you have the exact same thing on the top and the bottom, they'll cancel. So we have a cos B and a cos B. They're going to cancel with each other. A cos A and a cos A will cancel. And we have a cos A and a cos A and a cos B and a cos B. So anything divided by itself is 1. and that is as much as we can cancel. But we have to remember that if we have sin of A over cos of A is going to be equal to tan of A, and similarly sin of B over cos of B is going to be equal to tan of B. So this here is going to be equal to tan A, and anything divided by itself is 1, and this is going to be equal to tan B, sin B over cos B. This, the same thing divided by itself, is 1. So then we have sin A divided by cos A, so is tan A, and sin B divided by cos B is tan B. So now we have our expression, which is tan A plus B. So if you want to write it out at the end, tan A plus B is equal to this here. So tan A plus tan B, and then 1 minus tan A tan B. So that is our formal proof written out.